Hey, Eli.
Hi.
How are you?
Good.
Good. Do you want to work on yesterday's classwork stuff, or do you want to start on the quiz that I'm trying to see what page it was on?
I think it was 254.
The quiz was? Or do you want to work on some of the classwork from yesterday? Or both? The classwork started on 254 and then the quiz was on 256. The classwork was numbers 5 through 35. And then there was a quiz that you're supposed to do on page 256. There was 9 problems there. How are you doing on the work numbers 5 through 35? Because we did 1 through 3 in class yesterday. How are you doing on 5 through 35 on page 254?
I'm having trouble with 11 through 21 on the classwork, 5 through 35 odd.
Okay. All right. Well, let's start there then. Let's start with number 11. The instructions are write an equation in standard form of the line that passes through the given point and has the given slope m, or that passes through the 2 given points. So some of them, they're going to give us a point and the slope, and some of them, they're going to give us 2 points where we have to find the slope. So if you're given a point and the slope, you're just going to go ahead and plug that into point slope formula, which that's this formula right here. So we'll plug in y minus 2 equals, and then the slope is 1. So I can write 1 here if I want to, or I don't have to write anything, okay? So we've got x minus a minus 3, which that's technically plus 3, but I don't know if you skip that step or not. Do you? Do you go ahead and write plus 3? How do you handle that? On that part, when you're plugging it in here. Are you there? Oh, I think I lost you. Oh, hey, everybody. I just clicked back over. I just wanted to make sure I didn't lose anybody. Then you go ahead and distribute your 1 throughout. Like I say, you didn't really have to write it, but I did it just to make sure you could see that all you're doing is plugging in the point and the slope into each one. And now we're going to solve by combining our constants, which that's everything that doesn't have a variable attached to it. And it's a minus 2 on the left. So we'll add, because you do the inverse operation in order to cancel it. So now we have x plus 5. And now this is actually in slope-intercept form, because we have the slope and the y-intercept, but we want to take it to standard form. And for standard form, your x term and your y term have to be on the same side and the left side of the equation. So in order for that to happen, we have negative x, or we're going to subtract x, because you can't just move the x. You actually have to do the inverse operation to get it to the other side. So now we have minus x plus y equals 5. Now, I'm going to tell everybody here on Math Lab, if you guys get it to here, this is standard form. And Mrs. Sparks is perfectly happy with this answer for a quiz or a test. I'm ecstatic with this. Shh. Okay, so if you want to, as I said yesterday in class, mathematicians prefer standard form to be without a negative or without a fraction. So the AX term, that leading term, needs to be a non-negative integer. So for this one, you would actually divide both sides all the way through by a -1, which would just change the sign all the way through to that. But tomorrow on the quiz, if you get to here, I'm fine. If you do this, you get a +1. And hold on just 1 second. Everybody hold that thought for just a minute. I apologize.
I finished all my homework last night. I said no rehearsal today.
Okay, good job. Okay, sorry about that. Handling things for the day. All right, does everybody understand? Oh, that's what I was like. Why is that +1 written there? But I forgot I told you guys I was going to give you bonus. I was like, hello. But, all right, so that's number 11. But if you get to here, and I actually even think that right there that I just circled, if I'm not mistaken, these are odd problems, so you can look up the answer in the back of the book. If I'm not mistaken, that's the answer that's in the back of the book. So you can see that it's plenty happy that way. I just want you guys to understand that a lot of times that whole writing equations in equivalent forms, this is one of the reasons why, is because later on it's going to be more expected of you to be able to do this. So I just kind of want to start you guys off with that expectation. So that's number 11 from the classwork from yesterday. I think what I'm going to do is, okay, so that was number 11. Whoops. And then number 13 is just like that, where you're plugging in the point and the slope. Number 15 is just like that also, except it has a fraction in it. So I think I'm going to skip to that one and do that one because I know how much you guys love fractions. So I'm going to skip to that one. And I want everybody to know that I am getting to I will be getting to the quiz because I did have a few people that actually emailed me about questions on the quiz. So I want, if y'all will just hang tight with me while we work through a few of the problems on yesterday's classwork to make sure, because I didn't get to hit all of the different types of problems within the classwork. I hit all of the different types of problems, when we went through the examples, but I want to make sure that I'm getting through each type from each section on the classwork to make sure that you have an example. So my suggestion to you is to make sure that that you're writing these examples down in your math notebook so that you have examples to follow. And it never hurts to write yourself some additional instructions as to what exactly some of the things I'm saying. And I will give you some ideas of what that looks like too as I'm going through this. So number 15, once again, we're supposed to write an equation in standard form that goes through the line or goes through the given point, which here is -4 and -4, and m equals -3/2. And it's really not that bad. But what we're going to do is we're going to plug it in to point slope form because we're given a point and we're given the slope. So that kind of tells us which form to use. This is point slope. So it's y, and then we've got a minus -4. So that would make this plus. And then the slope is -3/2. So we're plugging in the 3/2 for the m. And then we've got x minus a -4. So once again, that's going to be +4 over here as well. And now we need to distribute this -3/2 to the x and to the 4. So I'm going to do my side work over here. This is me distributing the -3/2 to the 4. But basically what we're doing is multiplying. So simplify before you multiply. So -3 times 2 is -6. All over 1 is just a -6. Okay. And now we want to combine our constant term, which we've got one on the left. That's this +4. And in order to get it to the right, we have to do the inverse operation, which when it's +4, you need to do -4 on each side. This moves us into slope-intercept form because this actually has the slope and the y-intercept. I'm just writing these down because I want you all to see them because that's on the quiz tomorrow. But it's asking, the original instructions say to move it into standard form. So that means I need to move that 3x to the left. And I can't just move it. I have to do the inverse operation when moving it from one side of the equation to the other. So 3/2 x plus y equals -10.
Miss Sparks, I just joined. What page are we on?
That was number 15 on the classwork from yesterday.
Oh, okay.
That would be page 254. All right. Now, I'm going to be perfectly happy if you all leave it here because on this one, it's not as pretty to get rid of the fraction as sometimes you would think. But in all honesty, does anybody want to guess what I could multiply this whole thing by in order to get rid of the fraction? Like I say, I'm going to be happy if you get it to here. It will not be counted as wrong. As a matter of fact,
Is it 2?
yes, it is 2. Hold. Okay. That is so awesome, Eli. I am so, so excited that you knew that. If you multiplied everything by 2, it would absolutely cancel that out. So, and like I say, you do not have to do this on the quiz. I'm just helping you guys see what to do. So if I multiply everything by 2, that side work looks like this. So this actually would become a 3. X, sorry, plus 2y equals negative 20. But once again, if you did not do that, this is worth 1 point bonus on the test. But if you get it to here, the answer is correct. As a matter of fact, that is the answer in the back of the book. So Mrs. Sparks is completely happy. Huh?
What problem is this? What problem is this?
That was number 15 on page 254. This is the answer at the back of the book. This is for extra points. And I'm just showing you guys, I'm trying to kind of combine all of the things that we're writing. Writing the equivalent equations and getting things into standard form. I'm also trying to review all of the different forms that we've learned. The slope intercept and the point slope and standard. So we've gone over number 11 and we've gone over number 15, and now I'm getting ready to do 17. And then I will do one from the section about the horizontal and vertical lines.
Do you have the answer? Do you have number 11 still up there?
I do not have number 11 still up there. I can give you the answer if you would like. It is in the back of the book, though.
Oh.
All the odd problems, the answers are in the back of the book. I wouldn't want you to just write down the answer because that's not very helpful to you. It's not going to help you on a quiz or a test. The reason why we typically give the odd problems, though, is there's nothing more gratifying than working through all of this and looking in the back of the book and realizing that you, in fact, did everything correct. That's a wonderful, wonderful feeling, and that's the reason why Mrs. Sparks does that. It's a little sad sometimes when you look back there and it's not the same one. And like I say, on these, if you're going that extra step or going the extra mile for Mrs. Sparks and actually converting it to the AX term to a non-negative integer and not having a fraction or a negative, you might see that your answer isn't in the back of the book. But what you would want to do is look back in your work and see that you got it right. And then I can just help you make sure that you get that other. Grayson, the answer to number 11. The original answer looks like this, and this is the one that's in the back of the book. What Mrs. Sparks asked for was this, because you multiplied the whole thing through by a negative. My heavens to Betsy. Okay, number 17. -8, 4, and 4, -4. So this time we're not given the slope. So we have to find the slope before we plug it in to the point slope form. So the formula for slope is y2 minus y1 over x2 minus x1. So I'm going to substitute in for my y's -4 minus 4 all over 4 minus a -8. So the top is -8 and the bottom is 4 minus a minus 8. So that's going to be a positive 12 because that turns into 4 plus 8. This reduces to negative 2/3. So my slope is negative 2/3. Now we want to plug that in to point slope form, and we can pick either point. I am going to pick this point, 4 and negative 4. So y minus a minus 4 is going to be y plus 4 equals negative 2/3 x minus 4. So y plus 4 equals negative 2/3 x minus, or actually plus, because I'm multiplying. I'm going to show you my side work. Negative 2/3 times negative 4 over 1. So that's going to be plus 8 over 3. Y'all are loving the fractions, I know. Did I do that right? Okay. Now, oh yeah, oh, this is exciting. Now we have to combine our constants. So I'm going to subtract negative 4 from both sides. All right. I cannot, over here, I got exactly what I needed, but over here, I've got a positive 8 over 3 and a negative 4. So I have to change this negative 4 to something that has a common denominator with the 8 over 3. So I have 8 over 3. And then I'm going to have plus a negative. Now, this is negative 4 over 1. So 3 goes into 1 because this would be a negative 4 over 1. Maybe I should show that. Up here. 8 over 3 plus 4 over 1. I have to have a common denominator. So 1 goes into 3 times, and 3 times 4 is 12. So now I've got 8 over 3 plus a negative 12/3, which that then 8 minus 12, that's going to be a negative 4/3. Love you. Drive careful. Negative 2/3 x minus 4/3. So now I have to get my x over to the left-hand side. I can't just move it. I have to do the inverse operation. So I'm going to add 2/3 x to both sides. So 2/3 x plus y equals negative 4/3. Now, once again, Mrs. Sparks is completely happy if you get it there. It is in the back of the book that way. But can anybody tell me what I could multiply this whole thing by in order to get rid of the fractions and for you guys to be a prettier equation?
Would it be a 2?
Anyone tell me? I'm sorry?
Would it be 2?
It wouldn't, I mean, you could multiply it by 2, but that wouldn't get rid of your fractions. What would get rid of your fraction?
If you multiply it by 3 over 2.
If you yes, you could multiply it by 3 over 2, or you could multiply it just by 3 if you wanted to. 3 over 2 would definitely work for sure. Absolutely, Courtney, it would absolutely work. But if you wanted to do it, you know, with just a 3, that's totally going to work also. Just the denominator will work. If that would make it more user-friendly for you guys, which I feel like if you all can minimize the fractions, it makes you all happier. But if you multiplied, this all the way through by a 3, it would get rid of the denominator and you would end up with 2x plus 3y equals -4. So you really only have to multiply by the denominator, but I'm really proud of you, Courtney, that you saw that you could multiply by the reciprocal, because that's very similar to clearing the fraction when solving an algebra problem. So that's awesome. And yes, you could do that, but I'm trying to make this as user-friendly as possible for you guys, because I know that y'all are not always stoked when Miss Sparks has lots of fractions. And this particular one had lots of fractions. So I hope you all had an opportunity to kind of work through each of those steps and write them down. And I also want to note that number 17 that we just worked out is also circled with a red circle in the book. And that red circle indicates that it is also worked fully out in the back of the book in the section that actually has they're kind of highlighted in red in the margin. And I believe it says additional answers. And it is worked completely out, and it is there for you all to use as a reference. They did not do the extra step that Mrs. Sparks does. It is definitely left with the leading fraction.
Can we do number 19?
Number 19. Yes, we can do number 19. And then I need to move on to 20. I'm sorry, say that again.
On number 17, instead of having -4 over 3, I got -1.3 repeated.
Is that because you multiplied by 3 over 2? Oh, I got what you said. I know exactly what you're saying. I know exactly what you're saying. And that is fine. That is what -4 over 3 is. It's in decimal form.
So
you got -1. But
what
I'm asking, did you?
33.
Let me confirm that you're saying you got this. Is that what you're saying that you got?
Yes.
Okay. All right. Yeah, that is -4 over 3 in decimal terms. And if you wanted to leave it like that, you could. It is sometimes it can be a little more difficult to work with repeating decimal. You can't have that for your slope, though. A decimal doesn't work for slope. But it is definitely okay when you're dealing, because slope is a proportion or a ratio. And typically what I want you guys to remember is that X term is associated more with the slope, but your constant can be a decimal if you want it to be. So you could leave it like that if you wanted to, Courtney. Great question.
Okay, that's just how the calculator brought it up.
Yes. Yeah. And definitely when you're some of those calculators can switch to fractions, but I can't remember if is there a fraction mode on the calculator that we recommend for y'all?
I mean, you can.
Some of them have fraction modes. Okay. Some of them have them, some of them don't. Okay, number 19. Okay, we're given 2 points. So we're going to find the slope first. So we've got -9 minus a -1 on the top and a -6 minus 0. This is a special point. Does anybody know what that special point is? -9 plus 1, -8 over -6. That's actually the y-intercept of the equation. That one with the 0. Remember, when it has a 0 in the x, it is the y-intercept. Okay, so we have -8 over -6, which reduces to -4 over 3. -3, which is a positive 4/3. Okay, so now I'm going to pick a point to put in for the slope intercept, or the point slope, my apologies. Y minus a -1 equals 4/3 minus x minus 0. Y plus 1 equals 4/3 x. And then 4/3 times 0 is nothing. So I'm going to add, or I'm going to move my constant to the left. And now I'm in slope intercept form. And now I'm going to move my x to the other side. I hate that I go sideways. I wish I was better about that. So I've got -4/3 x plus y equals -1. And once again, I believe this is the answer in the back of the book, so you could leave it there for sure. But if you wanted to get rid of the fraction, you could multiply the whole thing by 3, and it would give you -4. Actually, a -3 is what I want to do, because I want to get rid of the -2. So give me 4x minus 3y equals 4. But did everybody get to hear who did it before me? How are we doing?
I
on
got
that?
them.
You got there? Is that Mary Faith that just said that?
Yeah.
Okay. All right. So if you're getting to that -4/3 x and y'all are looking up these answers in the back of the book and you're getting there, please know that Mrs. Sparks is happy. But I just want you to understand why they have us walk through that, whole thing of learning the equivalent equation thing. And that is definitely, there will be questions like that on the ACT and the SAT for equivalent equations. Seems like they always throw one of those in there. But that was number 19. And this is the answer in the back of the book. This is an extra step. All right, I am going to move on to number 23. And I want to get to number 31 also. But I definitely have a lot of questions that have been asked of me with regard to the quiz that's on page 256, I believe it is. So I definitely want to get to those before Math Lab's done. So these next few, please write them down as examples to kind of guide and lead you through how to do the problems in the section. So number 23, the example that I'm about to do will help you do number 25 and 27. The instructions say horizontal and vertical lines. Write equations of the horizontal and vertical lines that pass through the given point. And the given point is 3 and 2. So the vertical line that passes through the given point is x equals 3. That is the vertical line. The horizontal line is y equals 2. And you don't have to write completely out, vertical. You can put a V and an H, and I'm fine with that. And this is, even though we have lots of equations that look all fancy, like 2x plus y equals 4 and stuff like that, this x equals 3 is an equation of a line, and it is a vertical line. And y equals 2 is an equation of a line, and it is a horizontal line. Does anybody remember what the slope of a vertical line is? And the slope of a horizontal line. Anybody remember? You can type it if you are too nervous to speak.
Is the vertical line 0?
Vertical line 0.
Other way. The vertical line is the undefined one, and the horizontal line is 0. Because remember, you can't ski off a vertical line, you'd be undefined. And a horizontal line is 0 fun.
Are we not supposed to do 21?
We're not supposed to do 21.
Yes, you are supposed to do 21. I'm only doing a few from each section because I'm trying to get to the quiz also. And what you're supposed to do is write down some of the examples from each of the sections. I'm trying to cover ones that people have specifically asked me about in each section. And then if there aren't any that have been specifically asked, I'm trying to do at least one example from every section. And then I'm going to cover number 29 also, the error analysis. Error analysis. Describe and correct the error in finding the value of A for the equation AX minus 3Y equals 5. If the graph of the equation passes through the point 1 and -4. Can anybody tell me what their mistake was up front?
So all we have to do for 23 is the x is vertical and the y is horizontal. Is that right?
For number 23, what I just did? Yes.
Oh, so that's the same for like all of them.
Yes. For 25 and 27, you do the exact same thing. You just need to know which one is vertical and which one is horizontal.
Were we supposed to add?
Okay.
29 on 29.
They actually accidentally plugged in the wrong coordinates for each one of the, but I see what you're saying. Yeah, they actually plugged in the wrong coordinates. Like they plugged in, they've got 1 and -4 as the ordered pair, and they plugged in a 1 for the y and a -4 for the x. But yeah, they were also supposed to add, so I kind of see what you're saying. That, yeah, they didn't even do that part right. So they did a whole bunch wrong. For sure. So I'm going to kind of work that one out over here. Oh, not there. So number 29, yeah, because they did a lot wrong. Because I see what you're saying also, Eli. We've got ax minus 3y equals 5. And the point was 1, -4. And we're supposed to, they want to find the value of a. So what they would do is you would have to plug in a1, which I think they plugged in a -4 for that one, minus 3 times 1, which they plugged in the -4 there times, I'm sorry. They were supposed to plug in the -4 there. And they did that vice versa in the error. They actually plugged in the -4 here and the 1 there. And so they did that in reverse. So then you would have a1, and then -3 times -4 is 12. And then they would subtract 12 from both sides. You would have a1 or just a, because anything times 1 is itself. So the answer is actually a equals -7. So you would rewrite that like this. But good catch on the adding thing, Eli. So that's the error analysis for number 29. And now I'm going to do one more example like these. I'm going to do number 31, and then I'm going to move on to the quiz on page 256, because I've got 3 or 4 problems that I need to do on that one that I have been emailed about. So I hope that you're writing some of these examples down, writing these down so that you'll have them as a reference for completing the rest of your assignments. I may not make it through every single problem today on Math Lab, but there will be plenty of examples for you guys here, and for you to be able to complete it on your own. Number 31. Ax plus 3y equals 5. And it's 2, -1 is the point. So what we're asked to do is find the missing coefficient in the equation of the line that passes through the given point and write the completed equation. So the missing coefficient, the coefficient is that number which precedes the variable. So the missing coefficient for this one is the a. So what we want to do is plug in the coordinates from the ordered pair given into our x and into our y, and then we'll solve for that a, which is the missing coefficient. So we've got a times, this is the x coordinate, 2 plus 3 times -1 equals 5. So we've got a, you can write it as a2, or you could write it as 2a Either way is fine. And then a positive 3 times a negative 1 is a negative 3 equals 5. Now I'm going to add 3 to both sides because we want to move in closer and closer to our missing term. So that's 8A2 or 2A. So we're trying to get to A, and this is a multiplication, and to undo multiplication, you divide. So this is being multiplied by 2, so we're going to divide both sides by 2, and that's A equals 4. So now we have our A term, but the next part of the instruction says to go back and fill in and rewrite the equation with the missing coefficient. So you just plug in that 4 for A, and that would be your final answer. 4x plus 3y equals 5, because A equals 4. So that's the A, and then this is the rewritten equation. And that is an example for number 33 and 35. Those are the 2 additional problems that you'll work for that section. Did everybody get this written down?
Yes, ma'am.
Yes, ma'am.
Okay, good. All right, I'm going to move on to the quiz on page 256. And let's see, specifically, these are the questions that were emailed to me so you guys can know which ones that I'm going to cover. One, 5, 6, and 9 are the ones that I'm definitely covering. So I don't know if you had additional ones, if anyone else, just you can text them to me, you can email them, you can text them in the chat box, or you can email me, and I'll try to get them. Okay, number 1 says to write an equation in slope-intercept form of the line that passes through the given point and has the given slope m. Two, 5, and m equals 3. So what I'm going to do for this is start in slope intercept. I'm just going to go ahead and write it actually. Y equals mx plus b. So I'm trying to get it to this, but what I'm only given the slope and a point. So I want to plug in my point to solve for b. So I've got 5 equals 6 plus b. I'm going to subtract 6 from each side. It gives me -1 equals b. So now I know my slope, and now I know my b. So to put it in slope-intercept form, I've got y equals 3x minus 1. And that's my answer.
Miss Sparks, can you scroll up a little bit?
Like this?
Yes, thank you.
You're welcome. All right, you good, Mary Faith?
Yes,
Is there
ma'am.
anybody that needs me to do 2 and 3? Or can I move on to 4 and 5?
Wait, can you leave that up for a second, please? Or is it too late?
Do you need me to rewrite that?
Well, I had to run and get paper because I was out of paper.
Okay, do you need me to rewrite that?
If it's not a big deal, then
Oops. Okay, I clicked over to see if anybody needed me to do number 2 and 3. And I didn't see that, so I am going to move on to number 4 for the quiz on page 256. It says write an equation in slope-intercept form of the line that passes through the given points. And the points are 0, 2, and 9, 5. And the good news for this one is that is the y-intercept. So we really only need to find the slope. So we'll find the slope by doing 5 minus 2 all over 9 minus 0. So that's 3 over 9, which reduces to 1/3. So my slope is 1/3. So now all I have to do is plug in what I know into the slope-intercept form. And I know that the slope is 1/3. And I know that the y-intercept is 2. Because when the x is 0, that you know, when the x coordinate is 0, you know that this is the y-intercept.
How can you tell if it's not 0?
How can you get the y-intercept if it's not 0? Is that, I'm just making sure I understand your question.
Yes.
Because that is a great question, and that's what we're going to do for number 5. So you'll get to see that. So that's a really good question. We're going to actually have to choose one of the points and plug it into that equation. Good question. You set me up as always, Eli. I appreciate that. I love your leading questions. Y'all all ask really good questions, and I'm proud of how hard y'all work, and I appreciate you showing up for Math Lab. I'm really proud of all of you. It says a lot about your character and how hard you work. Number 5. Five, 7 are the points, and 19 and 14. I did get an email that said to do number 7. So I'm adding that. I had said I was doing 1, 5, 6, and 9. I had an email that said to do number 4, and I had an email that said to do number 7. So I'm just letting you guys know those are, so I'm going to do 1, 4, 5, 6, 9, and 7. That's almost all of them. So if that's not in the ones that you have a question about, please let me know. Okay. So back to this, write an equation in slope-intercept form of the line that passes through the given points. So the very first thing we're going to do is find slope. That seems to be a theme throughout this chapter, is to find the slope. When all else fails, find the slope. So once again, just as a reminder, I haven't been doing this, but just for the sake of reminding everybody what that slope formula looks like, I am going to write it one more time just to remind everybody. So we have 14 minus 7 all over 19 minus 5. So 14 minus 7 is 7, and 19 minus 5 is 14. So then that reduces to 1/2. So my slope is 1/2. Now I'm going to take my slope intercept form and plug in my slope and one of the points. And obviously on this one, this is going to be the favored point because I don't, just because I kind of want to keep my numbers small. So I'm going to plug in y equals 1/2 and then times, oops, my bad. Sorry, guys. 7 equals 1/2 times 5 plus b. So that's going to be, oh, y'all love these. So 5/2 plus b. And now I've got to subtract 5/2 from both sides. So I'm going to do my side work. That's 7 over 1 minus 5 over 2, which equals 1 goes into 2, 2 times, and 2 times 7 is 14, minus 5 over 2. So that equals 11 over, right? No, Miss Sparks. 9 over 2. So I have 9 over 2 equals B. So in slope-intercept form, I'm going to take my slope and my intercept and just plug those back into the equation. So y equals 1/2 x plus 9/2.
I got 4.5 instead of 9 over 2. Is that fine?
That is 9 over 2 is the 4.5 is the equivalent of 9 over 2. Yes, ma'am. It is. You know me though, Courtney. You know how much I like fractions so much better than decimals. I'm the opposite of all of you guys, I think, because I think all of y'all like decimals better. But I mean, I understand. I just trying to make sure I'm giving everybody the opportunity to write down. Everybody got that? Because I don't want to erase it. Okay, that was what? That was number 5, right? Whoops.
Yes, ma'am. Yes. Yes, ma'am. Yep.
Okay, so I'm going to do number 6. And I'm just going to let you guys know number 6 is ugly. The problems on the quiz are not as ugly as number 6. I mean, and when I say that, Courtney will have a prettier answer than I will, so we'll ask her answer. The y-intercept has it, and I will probably keep mine in fraction form, but Courtney will have my back and give y'all the decimal form, which I think y'all will like better. And not to put you on the spot, Courtney. I'm sorry. The points are 4 and 24 and -11 and 19. And we're supposed to put it in slope-intercept form. The very first thing we're going to do is find slope. So I have 19 minus 24 and -11 minus 4. So 19 minus 24 is -5, and -11 minus 4 is -15. So that reduces to a positive 1/3 because a negative divided by a negative is a positive, and 5 goes into -15. That reduces to 1/3. So, and now we're going to plug in what we know into the slope-intercept form, which is y equals mx plus b. So this looks like the most user-friendly point. So I will use that one because both of them have higher numbers. But we've got 24 equals, and then we've got 1/3 times 4 plus b. So 24 equals 4 over 3 plus b. And now I'm going to subtract 4 over 3 from both sides. So that's 24 over 1 minus a minus 4 over, oh, actually it'll just be, sorry about that, minus 4 over 3, which equals 1 goes into 3, 3 times, and 3 times 24 is 72 minus 4 over 3. So that is 68 over 3. Courtney, are you still with me? Because I'm sure everybody would love to hear the decimal.
Courtney's still here.
I can't do
What
it.
did you get for that?
I can't do it.
Okay. That, if you got the decimal, it would be this.
I got 22.6 repeating.
Yes, that's it. I just wrote it down. Good job. Yes.
I can't see it. I think like all the.
Oh, I'm sorry. I'm sorry. Is that better?
That's fine.
Okay. Sorry.
So you see that bar at the top of your screen?
So
Keep this thing on the left, and it makes everybody go away. Like, see that bar with the camera, the microphone?
Oh, for the profile photos.
Again, did you see them disappear?
and oh yeah, and if you make them disappear, you can see more of the screen.
Yeah, that's the point.
I don't make, yeah, I was going to say I don't make mine disappear because I like to see who's here.
Yeah, but then we can't.
But most of the time I'm over. Yeah, most of the time I'm over here anyway. Okay, so if you write it like Miss Sparks and keep it in fractions, it looks like this one. If you write it like Courtney, it would look like this. Or you could do a combination of Courtney and Miss Sparks, and it would look like this. No, it wouldn't. It would look like that. Any of those are acceptable.
Could you just do 22.6 repeating? Instead of like 666 and then repeating sign on top of the last 6?
Yes, yes. So did you do, let me make sure that I'm writing it exactly like you would like for me to and confirm that you're right. Did you do that or did you do this?
I just did 1/6.
That's fine. You're fine. You did this. Is that correct?
Yep.
Does that look right?
Yep.
Okay. All right. Did everybody get that written down? And that was number 6, right? Okay, so I'm getting ready to do number 7. The only ones I have for the next section that I've been emailed about are 7 and 9. But if someone would like me to do 8, you can either speak up or...
Miss Sparks,
Yes.
I have to leave shortly, so could you send us the video recording?
Could I post the video of Math Lab?
Yes, please.
Is that what you're asking? Yeah, I absolutely can do that.
Thank you.
You're welcome. All right. Number 7. Write an equation in point slope form and standard form of the line that passes through the given points. So we have -5 and 2 and -4 and 3. Very first thing we're going to do is find slope. Once again, that seems to be a pattern or a theme. So 3 minus 2 and negative 4 minus a minus 5. So that 3 minus 2 is 1. Negative 4 plus 5 is 1. So my slope is 1. And you would actually have a couple of options for this one. Because on the point slope, because everybody might pick a different equation. So I'm going to go ahead and write those in both formats so that you all can see both of them. But I want you to understand that when you move it to standard form, it actually will turn out to be the same. All right, so I'm going to pick this point first for point slope. So y minus 2 equals, and then you could either write a 1 or you could leave that just with nothing there at all, x plus 5. That's one of the options. Or you could write y minus 3 equals 1, or once again, you don't have to write anything, x plus 4. So those would be your options for the point slope. Either one of these would be correct. But to get it into standard form, you would have to distribute the 1, which basically 1 times anything is just itself. So I'm going to add 2 to both sides. And that gets me to y equals x plus 7. I'm going to move my x over to here. And I would have negative x plus y equals 7. So if you have that, great. I'm just going to, but if you did switch it and you have this, awesome. These are correct. Just to prove the point. Yes.
Okay, thanks.
So to prove the point, if you wanted to do this one, it turns out to be exactly the same. So standard form,
Could you scroll up a little bit?
that's standard form, and the above were point slope form. And look at this, along the way, we even got slope intercept. So that is the equation of that line. You get to see it in all 3 forms. Okay, I'm going to do number 9. and it follows the same instructions. You are given 2 points, and we are supposed to put it in point slope form and standard form. And the points given are 3, 9, and 1, 1. So the first thing we're going to do is find the slope. 1 minus 9 over 1 minus 3. So that gives me negative 8 over negative 2. So that m equals 4, because a negative divided by a negative is a positive. So now I'm going to pick this point first. I can pick either one to put it in point slope. Y minus 1 equals 4 times x minus 1. So that's this point in point slope. And the other point would look like this. Oops. So that is each point in point slope form. So y minus 1 equals 4x minus 4. Add 1 to both sides to combine our constants and get them over on one side. 4x minus 3. And now that one's actually in slope intercept, but to get it in standard form, I need my x and my y terms to be on the same side of the equation. So that gives me negative 4x plus y equals negative 3. Once again, now that is in standard form. Mrs. Sparks would be perfectly happy with that answer, but if you wanted to multiply it all the way through by a negative so that your leading term was a non-negative integer, it would look like that. But I am happy if you got to here. And just to prove that basically this turns out exactly the same, and that kind of proves the point. Here we are in slope, no pun intended. Here we are in slope intercept, which they're the same, and your standard form is the same. So it's interesting that your slope, your point slope, you can have unique and different equations for a line that kind of specifically speaks to a certain point on the line, but your slope intercept and your standard form will always look alike for this. Well, will typically look alike for that particular line. The way it might not look alike is that they can have some slight differences when you find quote unquote equivalent equations for that same line, which we did that exercise in 4.4. But I think we did almost all of them on the quiz. There's just a few for you guys to do to make sure that you're fully prepared. And please, please, please study your formulas also. That's why I tried to make sure I rewrote all of the formulas in today's math lab. Are there any other questions?
No, ma'am. No, ma'am.
Okay.
Thank you.
I appreciate you all coming. And I will see you guys tomorrow. I will go ahead, if you all want me to, I'm going to post. It takes about 10 or 15 minutes, sometimes up to 30 minutes for the video to actually process. And then I will be posting it on the Google Classroom. So if you want to go back and rewatch it, you can. Okay. Thank you all for coming. Have a blessed afternoon.
Thank you. You too.
Thank you. You too.